Hi, this is Melissa Muir. Welcome back for another installment of Tool Time Tuesday. Today I'm going to talk about annealing metal. Annealing your metal is so important in any aspect of metalsmithing. It's the process that we use to soften our metals. In glass lamp working though, annealing means to harden your glass, so it's a little bit confusing. But when we're metalsmithing, we use the term annealing metal to mean soften our metal and make it more malleable. As we work with our metal, it becomes hard. These couple of pieces of copper here, I ran through my rolling mill just to make sure that I could stiffen these up and make them nice and hard. You can see that even though I put pressure on these, I can bend this, I can change the shape of this. However, it is going to kind of spring back or resist my efforts to bend this metal. This is nice and hard stuff. I also have some 12 gauge wire that's half hard. This one is really difficult. I have to put a lot of pressure on this, and I don't know if you can see that in my fingernails there, but I have to put a lot of pressure on this to bend this wire, and getting it back is even more impossible. What happens when you work with your metal is it changes the crystalline structure of the metal itself. You can kind of think of the molecules as kind of at a party. When things first get going, people are kind of spread out, they have some room to move and mingle around. And then let's say that as we get more people to come into this party, everything gets kind of compacted a little bit more and a little bit more and a little bit more. And eventually what happens is everything becomes really, really tight and difficult to move. There's not a lot of movement here. So what we do then is we'll apply some heat with a torch, and it will start to spread things back out again. And those molecules then are free to move. Now, everybody, whether you have worked with metal or not, pretty much has seen this work hardening in action. If you think about taking a paper clip and you bend it back and forth, back and forth, back and forth, eventually that paper clip is going to break. That is that process of you hardening that metal and compacting that crystalline structure to the point where it can no longer move and it has no choice but then to break apart. So how do we know when our metal is annealed? Well, I'm going to show you a couple of tricks today to be able to kind of see when things are annealed. Now, depending on the type of material you're working with, there are also different ways of cooling that down, and we'll talk about that a little bit more in just a second. But one of my favorite tricks to do with copper is I take just a Sharpie pen and I'll just kind of create a little scribble on my surface. Okay, it doesn't even have to be that much, but what will happen is as we heat this up, you wait and you watch for that Sharpie to disappear, and once your Sharpie is gone, your metal is at that temperature to anneal it. Now that also works great for sterling silver. So another material that I'm going to work with is aluminum. Now aluminum melts very, very quickly. It has a much lower melting point than copper or sterling silver. And one of the things that I found that works really well for this one is just a regular old plain bar of soap. And I'm just going to go ahead and come in here and mark on my surface just with the soap. And it's kind of difficult to see if you can see that at all because there's not much pigment to that at all. So let's head back over to the torch now and see what to do for annealing. Okay, I use a pumice pan for annealing my materials. It's on a Lazy Susan, which makes it kind of nice because I can easily spin things around and make everything go into the position that I need to. I'm going to be using a jumbo torch here. Alright, and but this is just a butane torch. It's nice because it has a little larger flame, so I'm able to do pieces that are easily 2 inches by 2 inches wide. Anything larger than that, then I probably need to pull out my acetylene air torch. Now, things that I need to have in order to do this to keep things safe. One, my cross-locking tweezers that are insulated. They have little fiberglass inserts here that kind of help protect my finger from the heat traveling up to that. In addition, you're going to want to have a quench bowl or something that you can then take your hot metal and quench it quite quickly. Now again, like I said, depending on the type of material, you may not want to quench. Okay, I know that steel, that might be one that you'll let air dry. I'd always been taught that brass you would air dry, but apparently that's not always the case. So it just kind of depends. Aluminum, I will let that one air cool rather than quenching it quickly in the water. However, I have also quenched in the water. Just kind of play around and see what you think. You know, do some experimenting and see if you notice a difference in different materials. So what I'm going to do is I'm going to anneal the aluminum piece first. And what I'm going to do, you can see a little bit better here, the mark that is made from the soap. You want to watch for that soap to turn black. And once that soap has turned black, you want to stop, because what happens next is you begin to melt your piece. So I've got my torch, I've got it lit, and I'm just coming in. Now the hottest part of my flame is right here at the very tip of that flame. I don't know if you can see that blue cone that's right there, but that's the hottest part of my flame. And so you can see now this soap has turned black. Okay, and at that point my piece is now annealed. I could go ahead, set that to the side, and let it go from there. But I do want to show you really quickly how fast aluminum melts. I'm just going to work right here on this corner. Okay, and it does not take a lot of heat at all. You can kind of see that happening right there, I think. Alright, so you do want to be quite careful of what you're doing and as you're working with this. So I'll set that off to the side to go ahead and let that cool. Now the next thing I'm going to work with is this copper. There are a couple of different ways that you can work with copper to see if that it's annealed. You can watch for its color to change. You want to watch for kind of a light red glow, or you can do what we're doing here with the Sharpie, is you can watch that for that Sharpie to disappear, and here you can kind of see it disappearing. Okay. Alright, and at this point that is now cooled, or not cool, but it is kind of cool. And what you're seeing there is you're not actually seeing the Sharpie mark, you're just kind of seeing that ghost image. At this point, I'm going to go ahead and quench it. You heard that nice little psh. Love that sound. Okay. Another thing that you can do as you are annealing this metal is you can, like I said, you can watch for that color to change. Now with the copper, I've also noticed that as it gets heated, you'll notice that we have a lot of that oxidation happening here. Okay. So one of the things that I've noticed though is that when my metal becomes annealed, or right at that right temperature, the copper, because you'll see now, you see this oxidation that's happening, but where that flame touch it, again, it just looks like clean copper. And I've noticed that when it happens like that, then that particular part of the metal is now annealed. And so you can see here, I've got a little bit of that Sharpie left, but you see that red glow? Okay? That's how I know that, in the combination of that Sharpie being gone, that my metal is now annealed. And again, I've quenched it. You'd heard that it just went psh. It doesn't take a whole lot, and that's already cool enough to touch. Okay, and I showed you before how hard it was for me to bend this, and now you can see it bends very, very easily. Okay, it's almost a little thicker than butter, but it bends almost that easily. Okay, and I'm able to do a lot of shaping just with my fingers rather than having to have tools. As you work with your metal, it's going to be good and important to go through and often anneal your pieces. I've been working a lot with the hydraulic press lately, and this is essential when you take these to a silhouette die and you begin to try to puff or form your shape with the pressure of the press, because if your metal is not annealed, all that's going to happen is your metal is going to be sheared by the dies instead. I wanted to show you really quickly with the aluminum. The aluminum that I have, I think, is probably 16 or 14 gauge thick. I didn't gauge that, but I do know that it's at least that thick. This is a piece that has not yet been annealed. Okay, this is pretty stiff, like to the point where I cannot even get it to bend. Even though it's perforated, you would think that it would be easier to do that, but I'm putting quite a bit of pressure on this, and nothing is happening. This is the piece that I have just annealed. Okay, while it is a little bit stiffer than the copper was, even though the copper was like 20 gauge, which is a little thinner than this, but the copper is definitely much easier to move than the aluminum. But now you can see that I am able to easily form this just with my fingers. So even with the aluminum, again, it makes a huge difference.